Okay, we get to look at some application with circles. This is going to be fun. Now, anytime we talk about speed, speed involves time. You're used to speed like don't go over 65 miles per hour on the freeway kind of thing. But if you think about 65, that's miles per hour. So it's a length divided by a time. Miles per hour is a length divided by a time. Now, linear speed is like your speed on the freeway. However, angular speed is how quickly your wheels are turning. So if you think about, some of you are aware of this. If you have larger tires, you will go farther with the same spin, right? So angular speed is how quickly those wheels are turning, but linear speed is how far those wheels take you. So let me see if I still have up. I had found a fun little thing. Where did it go? Okay. I bookmarked it. Okay. So I've got this fun little thing to show you that shows you this. Interesting. This was voted as like one of the best things on Wikipedia. It's like really, really very useful to a lot of people. What this is showing you is it's explaining what pi is, but at the same time, you're able to see a circle turning, and watch as the circle turns, it's creating a path. When we look at our angular speed, we're looking at how quickly did that wheel turn. But when we look at linear speed, we're looking at how quickly is this line being created. And that's the difference between angular speed and linear speed. So angular speed, and I'm going to use the typical Greek letters that go with it. Angular speed uses lowercase omega. And what it is it is how many radians you go over however much time you decide, or over how much time it takes to go along that angular sweep. So it's just the angle measure divided by time. The time might be in seconds, the time might be in minutes, it could be a lot of different things. But we're going to stick with radians for the angle measure. But each individual problem will have its own time units. Now, linear speed is looking at how much of an arc did you actually pass through over that time. So it is arc length. And what I'm going to do is I'm going to use the letter V for speed. And it's equal to arc length. And arc length is used by the letter S, which is really awkward. So I'm going to actually we're going to replace this formula. But it is looking at the distance that you travel as an arc length divided by time. But now we need to back up and ask, well, what is the formula for arc length? And do you remember that we came up with the formula theta times r? So what that means is linear speed can be found by taking the length of the arc, theta times r, and divide by the amount of time. Now I want to point out to you something interesting. Theta times r divided by t can be written as r times theta over t. So I want you to see that there's also a really nice relationship between angular speed and linear speed. And that is my linear speed v is equal to the radius of the circle multiplied by the angular speed, omega. Make sure you have those formulas down, and then we're going to take a look at some examples. Oh, first I was going to make sure you were clear on angular speed. So angular speed is how fast something is turning. More, think about the wheels of a car, how fast those wheels are turning. But it is without regard to the size of the circle. However, if you change the side of the circle, that affects the linear speed. It affects the speed on the freeway. The linear speed is the speed based on how far you are actually traveling while you are turning. So angular speed is a rotational quickness. Linear speed is what you're used to thinking about. And I want to again show you that lovely GIF. Here we go. So angular speed is just how quickly it turns. Linear speed is how quickly that line is moving forward or backward. Okay, now, example. Nope, not ready for example yet. I forgot, I had more. Okay. So, how many radians are there in one revolution? That is my first question here. So, in other words, if you make one rotation, if it goes wee, 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 ding, full rotation, how many radians do you have there? How many radians is one full rotation of a circle? 2, 2. Thank you. 2 pi. Now, you might be told how many revolutions a circle has for a certain amount of time. For example, RPM. Does RPM sound really familiar to some of you? RPM is revolutions per minute.
Yeah, for those of us that use a lathe in the robotics team,
yeah,
very familiar.
Yes, the lathe that if you have, what are those called? The little, the reason we don't have those sweatshirt tie things for the hoodies.
Oh, the jacket ties? The hoodie ties?
Yes, the hoodie ties. The reason we have no hoodie ties on our sweatshirts, the lathe.
I know Mr. D's like he definitely
Yeah.
enforces that law.
Oh yeah. That has some nice RPMs to it that will
And also
pull.
the
Yeah.
green one, like it's emergency stop button. Even when you click it, it takes like a full minute to stop.
Are you kidding?
No,
Oh
no,
wow.
no. It's
Let's
like
not say
the other
let's not
ones.
say that out loud. Let's not say that out loud. It's a machine that you better bring safety with you. Anyway, okay, so RPMs, very, very important. Understand that with any of these problems that we're going to be looking at, if you are told how many revolutions per minute or how many revolutions per second, whatever you are told, if you want to know the angular speed, all you have to do is multiply that rate in revolutions per unit of time by how many radians one revolution is. So 2 pi multiplied by those number of revolutions per unit of time gives you your angular speed. Now, I believe I finally am now ready for the examples. Here we go. So, example 1. We want to find the angular speed of a bicycle wheel spinning at 100 revolutions per minute. So angular speed is how quickly it turns. We're looking at the turning speed. If there are 100 revolutions every minute, then the amount of angle that we go through per minute is 2 pi times the number of revolutions every minute. So 2 pi times 100, and that gives me 200 pi. You can leave your answer as 200 pi, or you can multiply and get the decimal number. That's up to you. But this is the number of radians per minute. Oh, I hear Under the Sea from the band. And then I just thought about it and realized that that's an old movie to you guys, isn't it? The Little Mermaid is an old movie. Okay. Sort of, kind of. Anyway, so that's the first part. Next, what is the linear speed of the bicycle? So what we found in part A was we found the angular speed of one wheel. So here's 2 wheels of a bicycle. I'm going to draw a horrible bicycle, so just deal with it. I'm trying to just draw it quickly. So there you go. Bicycle. You have your spinning wheels. We know how quickly those wheels are spinning. If we know that those wheels have a 24-inch diameter, we want to know the linear speed. How quickly is it moving forward? Now, if you look above just a little bit, if you know angular speed, how do you go from angular speed to linear speed? So V for linear speed is equal to, and what's the formula? I just need the radius of the circle multiplied by the angular speed, which is the 200 pi. And what is the radius of that bicycle wheel? The diameter is 24 inches. So what is the radius? 12. And so now you can leave pi in the answer, or you can write it in decimal form. That's going to give us 2400 pi. And then you want to look at what are the distance units we are using and what are the time units we are using. So it is 2400 times pi inches per minute. That is my linear speed. So that is how quickly the bicycle is actually traveling. Now, if you know how quickly the bicycle is traveling, you can figure out how far you go over a period of time. So if we want to know how far the bike travels in 1 hour, and we know its speed in terms of minutes, what do we need to do? So that means we are going to travel 2400 pi inches every minute for 60 minutes. And that gives us, what number does that give us? What is 2400 times 60 and then times pi?
Mine said 452,389 points.
Oh, you've got the decimal numbers. Hold on. You have the pi in it. So say that again.
Oh, you need to have the pi in it.
Oh, that's fine. Just tell me the number you just said again.
I got. Oh, yeah. I asked Siri, so this disappeared on me.
Oh.
I'll tell you in 1 second.
Okay. Does anyone have it with what is 6 times 24? You guys?
144,000 pi.
144,000 pi. And then you can also write that in decimal format as well. And what is that in decimal format? Does anyone have it? So just take that number and multiply it by pi. Okay. I may have written the answer down already. Let me see. So here I've got, you can leave it as pi format or you can write it in decimal format. That's up to you. And then I also estimated it as, so it's 452,388.96 inches, which happens to be just over 7 miles, which is a little bit more helpful. But there we go. Now, next problem says, what if the wheels have a diameter of 29 inches? So basically, this is asking you to kind of look at what you just did in parts A, B, and C to get to how far you traveled. This is dealing with the same angular speed. So what you want to be ready to manage is if you are told that a bicycle wheel spins at 100 revolutions per minute and the diameter of the wheels are 29 inches, can you take that information and determine how far the bicycle travels in 1 hour? So now let's look back at the process. We can find angular speed by taking the number of radians around a full revolution and multiplying it by the number of revolutions per minute. That gets us to our angular speed. Once we know our angular speed, to know the linear speed, we need to multiply that by the radius. And what is the radius of this circle? 29 halves. Now at this point, and let me put this down, this is angular speed. This is now giving me my linear speed. And then linear speed times time will give me my actual distance. Speed times time is distance. But it all depends on the units being used. The linear speed is revolutions per minute, knowing a length in inches. So this is telling me inches per minute for my linear speed. I want to know how far I go in 1 hour or 60 minutes. So I multiply that by my time, and I will get my distance. Linear speed times time equals distance. And then I want to double check. I'm dealing with a measurement of inches, so this multiplication will give me an answer of distance with respect to inches. I'm going to go over to the answers. And there you go. So I tried to color code it a little bit for you to see that you've got your omega, your angular speed, multiplied by your radius, multiplied by time. Okay, now for more examples. We're being asked to find angular and linear speed. If an object sweeps out a central angle of pi over 3 radians in 0.5 seconds. So that means it turns, this is about a pi over 3 angle. So we get a turning of something that is circular, goes this far, that much of an angle sweep in 0.5 seconds. What is the angular speed? It's how many radians was traveled over an amount of time in seconds. And what number does this give us? This gives us 2.09 radians per second. So that's the angular speed. You're asked to find the angular speed and then also find the linear speed. You want to remember that the linear speed has a really nice formula once you know the angular speed. The angular speed I'm representing with the letter, omega. Linear speed I'm representing with the letter V. Linear speed is the radius of the circle multiplied by that angular speed. So 3 meters multiplied by 2.09 radians per second. And that is going to equal 6.27. And what are the units on this? We want to look at what are the distance units we are using. We're using a distance in terms of meters. And then what are we using for our time units? Because this is giving us a distance divided by a time. So we have meters per second. Now I want to point something out to you that you don't have to know. I just want to point it out to you because it's an issue with units. You want to know that technically angle measure is unit free because angle measure is looked at as a ratio of two distances. If you go back to what a radian is by definition, or even what an angle is by definition. So all you need to understand is when we write angular speed, we need to express whether we're working with radians or degrees, because that will give us a different number here. But then when we convert that from how much of an angle sweep is made to an actual distance, we completely lose the radians, or if it were degrees, it would be gone. It's technically unit free. When we talk about angular speed and we say radians per second, we have to say something about the turn. The turning is the radians. But when we say radians, there's an understanding of what we are working with, but it isn't an actual unit as far as taking up a dimension kind of thing. But if that doesn't make sense to you, just don't even worry about it. I just wanted to point that out. Okay. And now, example 3. How many examples did I have planned? Okay. So example 3, here we go. If an object travels 35 feet in 2.7 seconds as it moves along a circle of radius 2 feet. Now, you can solve this problem however you want to go about this. I don't want you to feel like you have to use a formula. If you want to use a formula, use a formula. If you want to draw a picture, draw a picture. Word problems should follow some sense of logic. So I'm going to draw a circle, and I'm going to show that it's 2 feet. for its radius. Now, an object is traveling 35 feet. Now, one way I could look at it is it's moving along a circle. So it's moving along here. It's moving along the arc. It travels 35 feet in 2.7 seconds. Now, 35 feet means it's going to go around a few times. But by knowing that it travels 35 feet along a circle with a radius of 2 feet, and we are given how much time it takes, you can find either the linear or the angular speed first. Which one seems like it would be easier to do? The linear speed is looking at its actual speed as it is going along the circle. So what I could do is I could look at, all right, it travels 35 feet in 2.7 seconds. That 35 feet is the arc length. 35 feet is how far it went. I'm going to write down that it's S, which means arc length, and arc length is R times theta. My linear speed is how much distance I cover divided by how much time. That means my linear speed is that I traveled 35 feet in 2.7 seconds. The linear speed is just dividing how far by the amount of time. So what is 35 divided by 2.7? From there, once we get that answer, what is the relationship between linear and angular speed? My linear speed is represented by v. My linear speed is equal to the radius of the circle multiplied by the angular speed. So what I have is 35 divided by 2.7 gives me 12.96 feet per second. If I then use the formula that my linear speed is equal to radius times angular speed, I know my radius is 2 feet. I know my angular speed. I can write an equation. 12.96 equals 2 times angular speed. So to find my angular speed, I need to divide 12.96 by 2. And so that will give me 6.48 radians per second. So this example is kind of working backward from what we were doing before. And we have one more example. This time, an object moves at a constant linear speed of 10 meters per second around a circle of radius 4 meters. So I know my linear speed. And linear speed is using the letter V to represent it. I know my linear speed is 10 meters per second. Now the circle I'm traveling along has a radius of 4 meters. Well, that gives me my radius. And this is asking how large of a central angle is it going to sweep out in 3.1 seconds. So I want to know how much angle I get with 3.1 seconds. I want to know what my theta is equal to. Now we do know that linear speed, and you can solve this any way you want. People think differently. And I want you to use your logic. Your logic may be in kind of a reverse order than the way how things are presented mathematically. In that case, use your logic. You are very likely you're going to get this right. I want to remind you that angular speed is how much theta you get per unit of time. I'm using time in seconds. So angular speed is how much theta I have over time. The relationship between linear speed and angular speed is multiplying the angular speed by the radius. And I'm going to open your quiz up in just a minute. I'd like to give you a little more time to think about it. So if you are working on the video, you can pause the video. I know my linear speed is 10 meters per second. I know my radius is 4 meters. That means my angular speed is 10 divided by 2. Or sorry, 10 divided by 4, which is 5 divided by 2. That angular speed is equal to how many radians I cover over a period of time. So 5/2 is equal to, I'm trying to find theta, and the amount of time is 3.1 seconds. So basically I have 5 halves, which is 2.5, multiplied by 3.1, and that's going to tell me my angle. And however you go thinking about it, there are different ways you can process it. Ultimately, you should be getting 7.75 radians. I'm going to end